Hi, I'm Matteo Colombo. I'm a philosophy professor at Tilburg University in the Netherlands, and I research minds, brains, and computers.
I'm Cory Wright. I'm a philosophy professor, interim department chair, and director of graduate studies at California State University, Long Beach, in the United States. Professionally, my research concerns the nature and norms of explanation.
And I'm Angela Potochnik. I'm a philosophy professor at the University of Cincinnati, also in the U.S. I research methods in population biology, the nature of scientific explanation, and the relationship between science and the public.
We are the co-authors of the textbook Recipes for Science, which is an introduction to scientific methods and reasoning.
Everyone is impacted by science, from healthcare and new technology to our knowledge of life on Earth, human societies, and the universe itself.
So being able to understand and assess scientific methods and patterns of reasoning is a useful skill. This can help you make educated decisions about diet and exercise, medical care, how to raise children, how to think about problems facing society, and more. This also enables you to critically evaluate reports of scientific findings and the credentials of experts to decide what to believe and, perhaps even more importantly, why.
Speaking of, you might wonder why three philosophers should be taken seriously as experts about science. Scientists are, of course, the ones who conduct science. Other researchers have as their primary focus learning about how science works and how to relate to public life. That includes philosophers of science, like us.
Recipes for Science starts by considering why science is important and how science is especially well situated to do what it does: produce scientific knowledge. We talk about how science relates to traditional knowledge across the world, how its institutions develop to formalize certain approaches and methods.
There's a lot of variety in what scientists do and what they aim to accomplish, but we also think there are some general recipes that are used over and over by different scientists in different ways to produce knowledge.
After that, we talk about key ways scientists investigate the world, including experiments, observational studies, computer simulations, and different kinds of scientific models. And we address key ways scientists reason from their investigations to conclusions about what the world is like.
We consider all the ways in which probabilities and statistical reasoning are important across science, and how to be on the lookout for misuses of statistics. Causal reasoning is also of central importance to science, and a number of techniques support science's abilities to generate causal knowledge.
We wrap up the book by considering how science leads to explanations of our world and to the development of scientific theories, and also how those theories have changed over the centuries and may continue to change in the future. And last of all, we consider how science relates to society and the changes and new challenges facing science today.
We've also worked with some other philosophers to make these short videos explaining some key concepts and puzzling ideas that arise in the Recipes for Science book.
If you are a student using the textbook, these videos might deepen your understanding of these topics. Your textbook will mention relevant videos along the way, and so you can watch the videos related to what you're reading.
But even if you aren't using the Recipes for Science textbook, these videos might be interesting just as a way to think about challenging or interesting features of science, such as how you can tell the difference between real science and fake science, how societal and personal values influence science, what's the deal with experiments, how big data is changing science, how the public is getting involved in conducting scientific research, and more.